moonshine whiskey.
Hi everybody, welcome to Paul's Guitar Workshop. Today we're going to be talking about potentiometers. I'm going to show you a little bit how they work, how you can test them, just the basics more or less. So just follow along. I hope you don't get confused. Before we start, don't forget to subscribe to my channel and hit the notification button and allow all the time. I also give away custom built guitars, so you want to be able to know when that video pops up. If you like this video, hit the like button, and you know the deal. Okay, let's get started. Okay, usually you have two different kinds of pods. You have a large one, like this one here, and you have a small one, like this one here. Now these pots come in different sizes, values, so to speak, which are 500K, which are normally used for humbucker pickups, but also have been used in single coil, like the P90s. But usually they're in humbucker pickups, the 500Ks. And these minis are also come in 500K or 250K, exactly like the large ones. The 250K is usually for single coil pickups, but right now we're talking about the size. We'll get to the whole difference in a minute about the 250 and the 500K and what they're used for. First of all, the difference is the circumference, as you can see. I like to use the larger ones because the travel distance is longer, and I can fine-tune my volume or my tone better when I have a less sensitive travel in longer distance travel. Whereas with the smaller one, it's a smaller distance, therefore it reacts a lot faster. And I'm not a big fan of the smaller ones. I have used them. If you don't have no choice due to your cavity, because some cavities won't fit these larger ones in, so you use the smaller ones. And that's the main reason for the smaller ones and the larger ones, in my opinion, is your guitar pocket or cavity that they go in. But they're still just as good. It's just I don't like the sensitivity of it and the short travel. I like the longer travel where I can fine-tune my volume or my tone. Don't forget the shafts are in different lengths. As you can see, this shaft is shorter than that shaft, and that has to do with how far it protrudes out of your guitar. That's why they make these shafts longer and shorter. You don't want a real long shaft on a pick guard cover like a Stratocaster or something, where the pick guard is so thin, and then you got the shaft sticking up, an inch or two over, and then you got your knob will only go down so far, and you got that big gap. So you want to make sure you get the right length on shaft when you're ordering these. And also watch out for the diameter of the shaft, because it may be smaller or larger than your pocket, your hole in your guitar, and you may have to make the hole larger, or you may have a lot of play in it. So make sure the diameter and the length is proper one you need for your guitar. That's about the gist of the length anyways. Now, getting to the difference, there's two different kinds also. There's a linear tapered pod, and then there's a audio tapered pod potentiometer. Now what the difference is, a lot of times you can see right here it says A500K. The 500, the A usually stands for audio. So this would normally be an audio tapered potentiometer pod. But now I have another one here which you can see looks just like the other ones, and it's also 500K, but it says B. When it says B, it's usually linear tapered pod. I'm going to show you the difference between an audio tapered pod and a linear tapered pod by hooking it up to a multimeter, and then we'll move on from there. Okay? Give me a minute to set it up. Okay, let me show you real quick what's going on here. Now I'm just going to use any old knob that I got. This says tone knob, so just ignore the tone, the word tone on it, because it makes no difference right now. We're just checking these pods and to see what they are. Okay, first thing you want to do is get your multimeter and turn it to the highest ohm, to your highest ohm. Now mine is 2000, considering that our highest ohm we need is 500. My next step is 200, so I'll go to 2000, or you can go to 10,000. Anything over 2000 or anything over 500 would work. But mine maxes out at 2000, and that's where I'm going to set it. So 2000 ohm. Then take one of your alligator clips. I put alligator clips on the end, and you're going to have 3 different terminals here. And if you look at it in this face right here, I call this L1, L2, and L3. L1 is usually the input. L2, which is in the middle, is the wiper, which we'll get to in a minute, and it's the output. And L3, it'll be the ground. Okay, you got that? Input, output, ground. 1, 2, 3. Okay, now if you take any pot and want to test it, because some don't have the value they say. Now I don't know exactly what value this has because I just pulled it out of something, but that's probably the reason I pulled it out. But it says A 500K, so this should be an audio tapered 500 ohm pot. Now to test it, just put one of your alligator clips on one end and the other alligator clip on the 2 outer terminals. And you don't have to turn it or nothing. It's going to read. If you try to turn the knob or nothing's going to change when you're on the 2 outer prongs. It's 461, so this is definitely less than what it says it has. So I would probably not even use this. If it had 480, the way I do it anyway, some people do it different. If it had 480, 490 or something like that, I would use it for a tone knob. But usually I want it to have at least what it says or more. You'll get them that say 500 and it'll be 520 or something. I can show you that in a minute. But this is definitely lower. But that's not the point. I want to show you how to test it to see if it's audio or linear, the difference. Now what we're going to do is we're going to slide something over here to where you can see the meter moving. And now take your alligator clips. Let me straighten this out here a little bit. Take your alligator clips, put them on L1 and L2, input, output. It doesn't matter which one goes on it as long as they're not touching and one is on L1 and L2. Now it's turned all the way in. I'm going to take a cap and I'm going to put that 10 towards that last terminal, the L3, just for reference line. Now it's screwed all the way clockwise in. Now it's at full volume, right? And it says 460. Now as we turn it down, it drops all the way down to 0. Now it's at 1. Right? Right. Now here's the difference between the audio and the audio tapered and the linear tapered. What I'm fixing to show you. Now normally, if I were to turn it to 5, it should be at 50% of 460. So what is it? 230. It should be at 230 at 50%, half of the volume. Now I'm going to turn it half volume, which would be 5. And look at there, we only have 88. That tells me when I turn it halfway and it's not 230 or close to it, it may not be right on the money, 200, 220, 240, that's fine, but it says 88. That tells me this is an audio tapered potentiometer. And the reason I don't like that is because it's not consistent from 0 to 10. Now watch, I'm going to turn it real slow. It's going up really slow. We're already at 4. We're at 5. We're at 6. Now it jumps up. We're at 7. We're close to, let's put it at 240. Let's call that 240. That's 7.5. That's volume 7.5. 7.5 on your dial. Let's just say 8. Okay, we'll say 8 on your dial, on your knob, right? And that's only half volume. So from 8 to 10, you got full volume. You know what I'm saying? Instead of at 250. So you have a slow increase of volume till you get to 8, and then you can go from 8 to 10 with a fast swell. Some people like that fast swell. But I personally want to have a volume that goes gradually up so I can control the volume at lower and higher rolls. So that's audio. Now I'm going to show you a linear tapered pod. Take the knob off. Now I don't have a large linear, so I'm going to take a small one. You see where that says B? 500K, and in front it says B. The B might be behind it too. That tells me that it should be a linear. Of course, I'm going to put it on the 2 outer ones just to see what it has. And look at there, it has 520. Now that's still a very good pot. Now I'm going to put it down in the middle so I can test it. Make sure nothing's touching. Now we have it on L1 and L2. There we go. Now when I go clockwise, excuse me, I have 521. Counterclockwise, I have 0. Now I'm going to put this knob on here again at full volume, bottomed out clockwise to the, so the 10, the number 10 faces that last L3 terminal. Now when I turn it, this is a linear, not audio. Now when I go to 0 and I start to go up, it instantly follows the percentage of travel. So when I'm at 5, I'm at 226. So I'm at 50%. I'm at 50% or close to it, 50% of the volume. Then when I go all the way up, it goes slowly. There we go. So now we're at 1, which would be off. Then I would go to 50. That would be half, 50% of my volume. And then it just gradually goes up. And that way I got total control of my volume at every section of that pot. If I want that volume just under 50%, I can tweak it down to 4. The good thing about the linear is, because when you look down at it, you know what I'm saying? You say, oh, well, I'm used to playing a 7. That's my sweet spot. 7's my sweet spot. Or 4's my sweet spot. It's hard to do with the audio tapered pot because it's not really 50% at 5. You know, it's not the gradual turn of it. So it's hard to get from where it was like at 8 to 10. 8 was 50%, and then it goes to 10, it was 100%. You know what I mean? So what do you want if you want 60%? How are you going to find that in between 8 and 10? But here, 60% is 6, 70% is 7, 80% is 8. That's in my opinion the best way to roll. So that's how a linear tapered and the audio tapered pots work. I hope that explains that for you. Okay. But like I said, you can wire them up different. Instead of using L1 with L2 and L3 being ground, you can do it the opposite way. L1 is really this one, and L2 is going to stay L2. And then this outer one, which was L1, would then be ground. And that would make it a left-hand guitar volume and pot. That way, you know, he has the same control. And now if you rather have it go to full volume when you turn it counterclockwise, you can also wire it up, you know, the opposite way. That's all you have to do to make that volume change direction and change the volume or the tone. Now that we got that audio and linear tapered pod situation down, and the 250 and the 500 and the size and the shaft, we got all that. Let's move on to exactly how a pot functions on the inside. Okay, I got a little diagram here that will kind of hopefully show you what's going on inside here. This is the pot potentiometer, and this is the way it looks. The center, of course, is the shaft. This is your L2, your L1, your L2 and L3, which is here. Alright, here's how this works. This is your wiper, which is connected to the shaft on L2. L2 is always your output. L1 would be your input. L3 would be your ground. Now what this does is it resists for frequency depending on where that wiper is. And it more or less makes your frequency ground out as it turns, which the more it grounds it out, the more the volume goes down. The less that it grounds out, the more volume you have. For instance, right here, this is your resistance strip. That wiper is turned almost all the way down counterclockwise. So that would be about 2 on your knob right there, right? If you're looking at your knob, that would be about 2. So there's a lot of resistance that's resisting that frequency from traveling into that output, right? And that's what that does. And as you turn it clockwise, it lets more frequency into your output direction. If that makes any sense. What it's really doing, though, is grounding your frequency more and more, because that is on ground, and that is almost like a ground line right there. The more you ground it, the less frequency comes through, the less volume. So if you were to, over here, turn your knob all the way up to 9, say, your knob's now setting at the number 9, you would have a lot less resistance. So that frequency would travel, a lot more frequency would travel into your L2, your output, and it has a lot less ground. So counterclockwise would more or less be grounding it out more, and clockwise would be grounding it out less. Volume up, volume down. I hope that explains it to you how it works inside there. And like I said, this would be totally opposite if you were to wire it up different. Okay? That's about, I think, how I look at it. Alrighty? Now, the difference between the 500 and the 250K pots is the 500K has a brighter overall tone than the 250K pot. The higher K pots tend to give you a cleaner, more punchier sound on the bass strings. And like I said, the 500 pots are usually paired with humbucker pickups, and the 250 pots are usually single coil. But the P90s, like I said, single coil, also I've seen them with 500K pots before too. With the 250K, because of the single coil has that higher overtone, the pots bleed a little bit more of the trouble out when they're 250 pots. And another little trick, if you're single coil bridge pickup, if you feel like your bridge pickup needs to be a lot brighter than what it is, you could take that bridge pickup and bypass the tone knob and wire it directly so it's directly volume and no tone. That'll give you a brighter tone, because just because you put your tone knob to 0 or to 1 thinking it's not doing anything, it's still doing something. And if you were to just bypass it completely with that bridge pickup, single coil now, it would give it a brighter tone, because the tone knob does something even though it's turned all the way down. But if you bypass it, it's just all pickup on the volume, and it'll give you a brighter tone. But normally the bridge pickup shares the same tone spot as the middle and neck pickup. Okay, that's just a little tip. Don't forget to subscribe to my channel and hit the notification button and allow all the time, because I also give away custom built guitars, so you want to be able to know when that video pops up. If you like this video, hit the like button